Alright guys, let's see how we can solve question 70 from the second chapter of the energy mechanics. And in this one we need to determine the force magnitude F and the direction theta measured clockwise from the positive y-axis that will cause the resultant R of the four applied forces to be direction to the right with a magnitude of 9 kilonewtons. So we have the information about the resultant of all these forces, which is going to have, first of all, it will be to the right. So if we look at the question, we have the positive x and y axis, which means the resultant only has x component, and that would be 9 kilonewtons. So 9I, and obviously since it's to the right, there is no j or y component. So basically that's our rx, and that is going to be our ry. And for finding the rx, basically we need to find sum of forces in x, which is going to be equal to 9, and we just have to find the x component of each of these forces. So let's start with the 7 kilonewton. It's going to be 7 cosine of 30 degrees. This will be the x component. 20 kilonewton only has y component, and we also have the x component of the 11 kilonewton. This one's also in positive direction, so 11 cosine of 30 degrees. And we're gonna have the x component of the f, which will be this one. First of all, is to the left, so will be negative, so negative f sine of theta. So we can find f sine of theta from here, which is 7 cosine of 30 plus, we can actually factor the cosine of 30, so 7 plus 11, 18 cosine of 30 degrees minus 9. And we can just find f based on the theta, so 18 cosine of 30 degrees minus 9 divided by sine of theta. And let's move on to the ry, sum of all forces in y equal 0, since there is no y component for r. So we have, actually all of these have y component. Let's start with the 7 sine of 30, which we know sine of 30 is 0.5, and this will be the y component. We have 20 upward, and keep in mind that the y component of 11 is downward, so minus 11 sine of 30, and we have the y component of f, which is minus f cosine of theta. So from here we can find f cosine of theta, which is basically, again, we can factor sine of theta from these two, so 7 minus 11 minus 4. Sine of theta is 0.5 plus 20. So this is going to be minus 2. This will be 18. And if we just put the value that we have for f. Alright, so here just notice that our y direction is actually downward. So which means this 7 and 20 will be negative. So these two are actually negative signs. So this is negative, and these two are positive. Not that it makes any difference in our equations, it's just I should have written these signs because our y, the positive y direction, is actually downward. Alright, so I'm just gonna plug in what we have in here for f in the second equation. So basically 18 cosine of 30 degrees minus 9 over sine of theta times cosine of theta. So this is basically our f is equal to 18. And I can just bring these two, which is cotan. If we go on the other side, it will be the tangent of theta, 18 cosine of 30 minus 9 divided by 18, or our theta would be tangent inverse of this value here. And yeah, this is going to give us 20.1 degrees. And now that we have the theta of finding the f is pretty easy. We can just put that theta in here and find the f. So our f would be 18 cosine of 30 minus 9 divided by sine of the angle that we found, 20.1. So our force F would be basically 19.17 kilonewton, and that's going to be the force F. We can also put it Obviously in the second equation too, we're going to get the same thing. And yeah, that's pretty much everything for this one. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.